In this video, we're going to talk through the worked out solutions to the back of the Unit 2C5 worksheet or the Unit 2C review worksheet. As I read through this first problem, we're seeing that we're writing an equation for the number of movie screens as a function of the number of years since 1990. It asks us to define the variable, so when we look at that, if I figure out what I would label the x and y axis, the x-axis would be labeled number of years since 1990, and y would be the number of movie screens. So when we look at the information, I see this 1500, and I recognize that is going to be the slope, because that's what is increasing by each year, or that's the rate. And then I also look and I see that in 1996, there were 29,690 movies. Well, when I look at that information, that's not the starting amount, that's not the y-intercept, but it is a point. I do know that in 1996, I know how many movies we have in that year. So if x is the number of years since 96, then in that year, since 1990, then in 1996, it's been 6 years since 1990, so this would be an x-coordinate of 6. Y is the number of movie screens, so the corresponding y value here would be 29,690. So when we look at that, this problem really gives you a slope and a point, and so when I see a slope and a point, I know that I can substitute into point-slope form, and when I do that, this is what I get. Y minus y1 equals the slope times x minus x1, and I distribute, and then add the 29,690 to both sides, and this is what I get for the equation. So my slope is 1500, the y-intercept happens to be 20,690, which if I interpret what that means when x is 0, meaning the starting amount when we're in 1990, that's how many movie screens there were. So in 1990, there were 20,690 movie screens. Some students like to use a table to reason through this, and so let's look at what the table would look like. We would start with 6, 29,690. And we have to work backwards to get to the year 1990, or when x is 0. So this is another way to do it. You still see that the y-intercept is 20,690. The next problem asks us to write an equation on the line that passes through the given point. So we're going to be given a point and parallel to a line. So they're going to give us an equation on the line. So when I see parallel, I know that the parallel lines have the same slope and different y-intercepts. So to have the same slope, I'd have to have a slope of -3. If we look at this picture, the point -1, 2 would be about there. Here's the equation, y equals -3x plus 1. So to be parallel, it would look something like this. Well, to be the same slope, the slope would be -3 and through that point. So I can substitute into point-slope form, and I get that. I can distribute and then convert to slope-intercept form, and there would be the equation in slope-intercept form. I could also make a table. I could start with the point that you're given, -1, 2, and realize if the slope's -3, every time x increases by 1, y will decrease by 3. So the y-intercept would be 0, -1, so you could use a table to do this as well. If we do the same thing over here, the slope would have to be 2/3 and through that point. So I can use point-slope form. Because it's -2, we'll see plus 2 in the equation. Because it's +3, we'll see -3 in the equation. We distribute and get y equals 2/3 x minus 4. Or you could use a table. The table gets a little trickier for some of us when we use the fractions for a slope. So realize if I add 3, I get all the way down to 6. Adding 2, I would get to 0. Subtracting 3 for x, I would get up to 0. So subtracting 2, I would get up to -4. So that's just working forwards and backwards in the table using that same slope. For this one to be perpendicular to the line, realize that to be perpendicular, the slopes are now opposite reciprocal. So I drew a quick picture here. This point is 6, 0. There's our point 6, 0 right here. The line y equals 2/3 x plus 4 would be right here. To be perpendicular, we have to form a right angle, so it would look like that. So if the slope is the opposite reciprocal, that slope would be -3/2. So I have a slope of -3/2, and I want to be through the point 6, 0. Again, I could substitute it into point-slope form, and this is what I would get. Y minus 0 equals -3/2 times x minus 6. I distribute. To the side, I did what 3/2 times 6 was. I get that simplifies to 9. Over here, same idea. The slope here is -1/5. To be perpendicular, the slope of the line would have to be 5. So I want a slope of 5 through the point 3, -7. I substitute into point-slope form, and then I can distribute and convert to slope-intercept form. Looking at number 11, it's asking me what is the slope of a line that is parallel to this line. Well, I know that they have to have the same slope. So if we're talking about slopes, slopes will be the same if they're parallel. But when I look at that equation, I don't know what the slope is. That's not in slope-intercept form. That's actually in standard form that we're going to start learning this next unit. So I convert it to slope-intercept form first. Add 4x to both sides. Divide everything by 2. I get y equals 2x plus 2. So the slope here is 2. So to be parallel, the slope would have to be 2. Perpendicular means the slope is the opposite reciprocal, so the slope would have to be -1/2 to be perpendicular. And then down here, when I look at this problem, it's asking me, of all these lines, which ones are parallel, which ones are perpendicular, and then if there's neither that are parallel nor perpendicular, we'll just write none. Well, to be parallel, I need the same slope and different y-intercept. So this has a slope of -2. I look at the rest of these, none of the rest have a slope of -2, so A will not be parallel to any of them. Here we have a slope of 1/2. None of the other ones have a slope of 1/2, so B will not be parallel to any other line. Here we have a slope of 2, and if I notice here, there's a slope of 2 as well, so C and D will be parallel. To be perpendicular, the slopes have to be opposite reciprocals. Well, if the slope here is -2, the opposite reciprocal would be +1/2. And B has a slope of +1/2, so A and B would be perpendicular. When I look over here to 2, the slope is 2, or sorry, line C, the slope is 2, so the slope of a line perpendicular would have to be a -1/2. None of them have a slope of -1/2, so nothing's going to be perpendicular to C. This one has a slope of 2 as well, and so nothing will be perpendicular to D. So A and B are the only ones that are perpendicular. And that is the back of the 2C review worksheet.